Here's something almost nobody thinks about. When a lion kills a gazelle, dinner is served. The lion eats. No preparation, no cooking, no storage. Kill, eat, done. For almost every animal on Earth, food goes straight from the environment into the mouth. Humans are the strange exception. Between the moment a prehistoric human obtained food and the moment they actually ate it, there was an entire hidden process. Butchering, pounding, heating, drying, storing. Some of these steps took minutes, some took days, and added together, across a lifetime, they represent one of the largest time investments our species has ever made. Today we're going to follow food from the kill, or the harvest, all the way to the mouth, step by step. And we're going to measure how long each stage actually took. Because the answer reveals something profound. Humans are not just the animal that eats. We are the animal that processes. And that single difference may be the reason we have the brains to think about it at all. Almost every animal eats food raw and immediately. Humans are the exception, and that exception rebuilt our bodies. Let's start with the most basic question. Why process food at all? Consider our closest relatives, chimpanzees. A chimpanzee spends roughly half of its waking life chewing, 6 hours a day, sometimes more. When a chimpanzee eats meat, which happens occasionally, it can chew a single carcass for hours. There is a documented case of a chimpanzee chewing one infant baboon for 9 hours. 6 hours a day of chewing. That's the default state of a large primate that doesn't process its food. Now think about yourself. How long do you spend actually chewing in a day? 20 minutes? 30? The gap between 6 hours and 30 minutes is the entire story of human food processing. Everything we're about to discuss exists to close that gap, to take food that would require hours of chewing and hours of digestion and make it edible in minutes. In 2016, Harvard researchers Catherine Zink and Daniel Lieberman published a landmark study in the journal Nature. They wanted to know what the simplest food processing, before cooking even entered the picture, did to human eating. They had volunteers chew various foods while measuring the muscular effort involved. Raw goat meat, raw vegetables, and the same foods after simple processing, slicing the meat, pounding the vegetables. The results were striking. Just slicing meat and pounding plants, no fire, no cooking, just mechanical processing with stone tools, reduced the effort of chewing by about 20%. Over a year, that adds up to roughly 2.5 million fewer chews. And here's the deeper finding. Raw meat, with human teeth, is almost impossible to eat. Lieberman described trying it himself, chewing raw goat and finding that the meat simply wouldn't break down. You chew and you chew and you chew and nothing happens. Human teeth can't process raw meat into swallowable pieces, which means processing wasn't a luxury. It was the thing that made an entire category of food available to us at all. A chimpanzee chews 6 hours a day. Simple slicing and pounding cut human chewing by 20%, about 2.5 million fewer chews a year. So let's follow the food. Stage 1. Butchering. A large animal, say a zebra or a deer, has been brought down. Now the real work begins. Butchering a large carcass is not quick. First, the hide must be removed, ideally intact, because it's a valuable resource in its own right. Then the body must be opened and the internal organs removed, many of which are nutritionally precious and eaten first because they spoil fastest. The liver, kidneys, brain, and marrow are prime targets. Then the meat must be separated from the bone. For a large animal, this is a multi-person job that can take several hours. Stone tools make it possible. A sharp flake can slice through hide and muscle far faster than teeth or hands ever could. But it still represents hours of skilled labor. And there's time pressure. In a warm climate, a carcass begins to spoil almost immediately. Flies arrive within minutes. Bacteria multiply. The group has a limited window to process everything before a significant portion becomes inedible or dangerous. This is why a large kill was often a frantic communal event. Everyone worked. The clock was running. And there was a strategy to the order of processing. The organs that spoil fastest and that carry the richest concentrations of fat, vitamins, and calories were consumed first, often right at the kill site. The brain, extraordinarily rich in fat, was a prize. Bone marrow, sealed inside the bone and protected from spoilage, was extracted by cracking the bones open with stones, a technique so old and so important that the smashed bone fragments left behind are some of the clearest archaeological signatures of early human activity. In fact, marrow extraction may have been one of the first ways our ancestors accessed dense, reliable calories that other scavengers couldn't reach. The muscle meat, what we think of as the meat, was in some ways the least urgent part because it could be preserved. The perishable treasures came first. Butchering a large animal was a multi-person job of several hours, done against a clock because in warm climates, meat spoils within hours. Stage 2, the first processing. Pounding, slicing, tenderizing. Even after butchering, much of the food wasn't ready. Meat, as we've seen, is nearly impossible to eat raw with human teeth. So it was sliced thin, increasing the surface area, making it chewable, making it dry faster later. Tough cuts were pounded between stones to break down the fibers. Plant foods needed similar treatment. Many wild tubers and roots are hard, fibrous, and full of compounds that make them difficult or even toxic to eat raw. Pounding them into a paste made them digestible. Some required soaking or leaching to remove bitter or poisonous compounds, a process that could take hours or even days of preparation before the food was safe. This stage is invisible in most of our imaginations of prehistoric life. We picture the hunt. We picture the fire. We rarely picture the hours of pounding roots against a grinding stone. But that labor was constant, daily, and mostly performed by women. And now, a question I'd love you to answer in the comments. Think about the last meal you made completely from scratch. Not assembled from packages, actually made, starting from raw ingredients with real time and effort. How long did it take? And here's the real question. Did it feel like a burden, or did it feel like something else? Something satisfying, even meditative? I'm asking because I think the answer connects to something very old in us. Drop it in the comments. I read them, and I think this one will surprise people. Stage 3. Heat. Cooking. This is the big one. The stage that may have made us human. Harvard biological anthropologist Richard Wrangham has spent decades arguing what's now called the cooking hypothesis, that the control of fire for cooking was the single most important development in human evolution. The logic is about energy. Cooking does something remarkable to food. It externalizes part of digestion. When you apply heat to starch, a process called gelatinization makes it dramatically easier to digest. Raw wheat starch is about 71% digestible. Cooked, it approaches 95% or more. Wrangham's research with Rachel Carmody estimated that cooking increases the net energy gained from food by around 30% on average. 30% more energy from the same food, just by applying heat. And it goes further. Cooked food is softer, so the body spends less energy digesting it. Cooked food kills parasites and pathogens. Cooked food can be eaten faster, freeing up hours of the day. Wrangham's argument is that this energy surplus is what paid for the human brain, an organ that consumes about a quarter of our resting energy. He points to the fact that around 1.8 to 1.9 million years ago, Homo erectus appeared with a bigger brain, a smaller gut, smaller teeth, and smaller jaws. Exactly the changes you'd expect if a species had outsourced part of its digestion to fire. Cooking increases the energy from food by about 30%. That surplus, Wrangham argues, is what paid for the human brain. But cooking isn't free. It costs time. This is the part the cooking hypothesis sometimes glosses over, and it's central to our question of how long food actually took. To cook, you first need fire. If the fire is already burning, good. If not, it must be started, which, with friction methods, can take significant time and effort and doesn't always succeed on the first try. Then fuel must be gathered, a task that, in wood-poor environments, could require substantial travel. Then the cooking itself must be managed. Roasting a tuber in coals takes time and attention. Interestingly, the Hadza, one of the most studied hunter-gatherer groups, often roast tubers only briefly, sometimes lightly, eating them partly raw. Research on Hadza tubers found roasting times averaging under 10 minutes for some species. So cooking wasn't always elaborate. But for meat, for making tough foods safe and digestible, it was a real and regular time cost. The trade was worth it. Time spent cooking was repaid many times over in energy gained and chewing time saved. But it was still time, a daily recurring investment that structured the rhythm of the day around the fire. And there's a subtle point here that's easy to miss. Cooking didn't just add energy, it added predictability. A raw diet is a gamble. Some foods are digestible, some aren't. Some are mildly toxic, some are fine only in certain seasons. Cooking flattened that uncertainty. It turned a wide range of marginal, difficult, or dangerous foods into reliable calories. It expanded the menu. Plants that were inedible raw became staples once fire entered the equation. In that sense, cooking didn't just feed the brain, it widened the entire foundation of what humans could survive on, which mattered enormously when the environment turned harsh. Stage 4, and this is the one almost everyone forgets: preservation. Here's the problem. A large kill produces far more meat than a group can eat before it spoils. A zebra is hundreds of kilograms of food. In a warm climate, without preservation, most of it would rot within days. So prehistoric humans developed one of the most important technologies in history: methods to make food last. The primary method was drying. Meat sliced into thin strips and hung in the sun or over a low, smoky fire loses its moisture, and without moisture, the bacteria that cause spoilage can't grow. Sun drying took 1 to 2 days. Drying over a smoky fire was faster, 4 to 8 hours, and the smoke added preservative compounds while repelling flies. The result was a food that could last for weeks, months, even years. The North American pemmican tradition, dried meat pounded into powder and mixed with rendered fat, produced a food so stable it could last for years in a rawhide container, packing around 3,500 calories per kilogram. Among the most calorie-dense, shelf-stable foods ever created from natural ingredients. Think about what this meant. Preservation broke the tyranny of immediate consumption. It meant a successful hunt could feed the group not just today, but through lean times. It was insurance. It was a battery for storing calories against an uncertain future. Preservation broke the tyranny of the immediate. Dried meat could last months or years, a battery for storing calories against hunger. And now, the second question for the comments: do you preserve any food yourself? Do you can, ferment, pickle, dry, smoke, freeze in a serious way? Did you learn it from a parent or grandparent? Or did you have to seek it out yourself because the knowledge had skipped a generation? I'm curious how much of this ancient knowledge still survives in your families. Tell me in the comments. I suspect the range of answers will be enormous. Now let's add it all up. How much time did food actually take from kill to mouth? Let's build a rough daily picture for a hunter-gatherer group. Acquiring food, hunting and gathering, took a few hours a day, distributed across the group. But that's just the beginning, and it's the part everyone already knows about. Then, butchering, when there was a kill, hours. Pounding and processing plants, a constant background task, 1 to 2 hours a day for the women doing it. Cooking, variable but a real daily presence, often another 1 to 2 hours around the fire. Preservation after a large kill, a major project spanning 1 to 2 days, though not every day. Added up, and food processing, everything after the food is obtained, could easily consume as much time as acquiring the food in the first place. Possibly more. This is the hidden half of prehistoric life. We talk endlessly about hunting and gathering, but the labor that happened after the hunt, in camp with stones and fire and drying racks, was just as large, just as skilled, and arguably more important. Processing food, after it was obtained, could take as much time as finding it, or more. This is the hidden half of prehistoric life. Let's go deeper on a few things that rarely get discussed. First, who did this work? The gendered pattern in most hunter-gatherer societies placed food processing predominantly with women. Men more often did the hunting, women did much of the gathering, and the great majority of the in-camp processing, the pounding, the cooking, the drying, the daily transformation of raw material into food. This means that when we picture the dramatic hunt as the center of prehistoric food, we're focusing on the wrong thing. The hunt was occasional and unpredictable. The processing was daily, reliable, and absolutely essential. A society can survive a bad hunting week. It cannot survive if no one processes the food into an edible, storable form. The invisible daily labor of food processing, overwhelmingly women's labor, was the actual foundation of the food system. Second, fire as the center of the home. The word focus comes from the Latin for hearth, the fireplace. In the ancient world, the hearth was the literal center of the home, and there's something deeply appropriate about that. The cooking fire structured daily life. It was where food was transformed. It was where people gathered at the end of the day. It was where the drying rack stood. It was warmth, light, safety, and cuisine all in one place. The management of that fire, keeping it alive, feeding it, controlling its heat for different cooking tasks, was a continuous responsibility. Letting the fire die could mean hours of work to restart it, so someone always tended it. The fire was, in a real sense, a member of the household that had to be constantly cared for. The word focus means hearth in Latin. The cooking fire was the literal center of the home, transforming food, gathering people, never allowed to die. Third, the knowledge required. Everything we've described required deep, specialized knowledge that took years to acquire. Which plants need leaching to remove toxins, and for how long? How thin to slice meat so it dries before it rots? How to read a fire's heat? Which woods smoke well and which taint the food? How to tell when dried meat is fully preserved versus dangerously underdone? When a stored food has turned and become unsafe? This wasn't intuition. It was a body of accumulated technical knowledge passed down across generations, refined over thousands of years. A young person didn't just watch. They served a long apprenticeship, absorbing a library of food knowledge that could mean the difference between nutrition and poisoning, between surviving winter and starving. In this sense, every prehistoric group carried an unwritten cookbook, and a food safety manual, and a preservation manual, entirely in human memory. Losing an elder meant losing part of that library. And consider how much of this knowledge is about avoiding disaster rather than achieving excellence. A single mistake, a poorly leached toxic root, a batch of dried meat that didn't fully cure, a stored food gone bad, could sicken or kill. Food processing was not just about making food tastier or more digestible. It was a continuous exercise in risk management, where the stakes were survival, and where the accumulated wisdom of generations was the only defense against 100 invisible dangers. Every safe meal was, in a sense, a small triumph of inherited knowledge over a natural world that offered as much poison as nourishment. Now step back and look at the whole picture. From the moment food was obtained to the moment it entered the mouth, prehistoric humans performed an elaborate sequence of transformations that no other animal performs. Butchering, slicing, pounding, leaching, cooking, drying, smoking, storing. Each step cost time. Together, they may have cost as much time as acquiring the food itself. And that investment was not optional. It was the price of being human. Because here's the profound thing. All of this processing did something to us over evolutionary time. By externalizing digestion, doing outside the body what other animals do inside it, we were freed from the 6-hour chewing day and the massive gut it requires. That freed energy. That energy built a brain. The brain that built the tools, that controlled the fire, that remembered the techniques. That processed the food. It's a loop. We process food, and food processing made the us that processes food. The next time you spend an hour cooking a meal, consider that you're performing one of the oldest and most defining human rituals there is. Not a chore, a birthright. The thing that, more than almost anything else, made us who we are. Kill to plate, harvest to mouth. That hidden journey, repeated billions of times across hundreds of thousands of years, is quietly one of the most important stories of our species.